What is meant by hybridization of atomic orbitals? We are supposed to describe the shapes of sp, sp2 and sp3 hybrid orbitals. See, hybridization is mixing of atomic orbitals on the same atom. The keywords are mixing of atomic orbitals on the same atom, comma, having same or nearly same energy two different orbitals which have very different energies can't mix. So, mixing of atomic orbitals on the same atom having either same or nearly same energies to produce hybrid orbitals. Before mixing, they could have been different. One could be S, another could be P. After mixing, they became same to produce identical hybrid orbitals. Identical hybrid orbitals having identical shape and energy. And this energy is just in between the energies of the orbitals which have undergone mixing. But of course, one identical, to produce one more number we should add, same number of. So if there are 3 atomic orbitals undergoing mixing, they will produce exactly 3 hybrid orbitals. If there are 4 atomic orbitals undergoing mixing, they will produce 4 atomic orbitals. So this is a very important sentence with a lot of keywords, please note. So let me repeat, what is hybridization? Hybridization is, first point, mixing of what? Atomic orbitals. And where are they? They are on the same atom, which have same or nearly same energies, okay, to produce same number of identical hybrid orbitals having identical shape and energy. There are 8 keywords in this single sentence of definition of hybridization, and each of them is unforgettable, indispensable, and very important. Do make sure that you don't eat away any part of it. This is hybridization. Then we are supposed to talk about the shapes of sp, sp2 and sp3. Let's take a look. Also watch, if we have p orbitals, px, py and pz, well, they might be alike, but then, see, this is px, py, pz, all mutually perpendicular orbitals, and s orbital is spherical in shape. Hybridization is when s and px mix. See, it is sp hybrid orbital, which is formed by mixing of one s and one p orbital. One s and two p orbitals. If you try to mix them, this is s, and within this you can see two p orbitals, px and py, and when we say let them mix, and you see as they begin to mix, you get 3 different orbitals. Orient them properly, and as you mix them, this is 1, 2 and 3 sp2 orbitals. What is this? Oh wow, we have sp3 by very similar logic. All 3 p orbitals along with one s, they will give you 4 sp3 hybrid orbitals like this. Those of you who may feel that, oh my God, that was a fantastic animation, but then how do I draw this on my own? Well, I could just give it to you like this. See, when you have s orbital and one of the 3 p orbitals mixing, you can say they can mix, and please understand, half filled, fully filled or empty, all three types of orbitals can undergo hybridization. So it doesn't matter whether they have electrons or they don't, or they're fully filled or half filled or empty. Just mix them. You take one s and one p. It has to be px only. It could be py, pz, whatever. Hana? But once they mix, they are no longer two different s and px. Rather, you get sp hybrid orbital, and this is how we should draw it. This is the shape of one sp hybrid orbital. There's a small tail also, a small balloon. Yeah. If this has positive, this is negative. Oh my God, that way, yes. In a similar fashion, you also have the second sp. So you get two sp hybrid orbitals. Initially, I did show you the shape of one sp hybrid orbitals, one orbital, and now that you have mixed s and p, two, so you have two hybrid orbitals, and they are what? They are sp hybrid orbitals. This is how actually you sketch them or draw them, right? If you want to be very accurate, although this is totally sufficient for NCERT, but in case you want to be more accurate, I can tell you that the accurate shape of a hybrid orbital is like more or less like this. It is more or less like a mushroom. I mean, this way. I mean, this is when my hand was not so dexterous. So this looks better. It has like this portion is symmetric to this portion. That way. This is more accurately the shape of a hybrid orbital. It is not like p orbitals. But since it is difficult to draw, people approximate that this is just draw like this, and it is sufficient. This, my dear, is how you draw hybrid orbitals. In case you are wondering, what about sp2 and sp3? It is exactly similar. I'll show it to you. S and 2p, S and all the 3p orbitals. If you take this, you get sp2. If you take all, you get sp3. 1s and 3p will give you 4 sp3 orbitals. You will get 3 sp2 orbitals like this. And what is the geometry like? Well, this is the way people make them. I'll draw them more cleanly, like this. And the small tail like this. So one black and one red balloon together make one sp2 orbital, and these are 3 sp2 hybrid orbitals. They are always at the corner of an equilateral triangle, and that is why the geometry associated with sp2 hybridization is trigonal planar. What about sp3? I'll show you that also. Can I erase this? I believe yes, I can. If you take this 4 case of sp3, what you get is, you have 1. I'll just draw lines for reference. You have 2, you have 3, and you have 4. Now please remember, it's a 3-dimensional structure, so this becomes a bit difficult to draw. Like this. These are sp3 hybrid orbitals. Don't they have tails? Yes, they have those chotu tails like this. Right? The geometry which is associated with sp3 hybridization is tetrahedral, and the bond angle which you get is 109 degrees, 28 minutes. Oh my God, we have to memorize that? Yes, we do need to do that. That's it.